Welcome to Lab 3 Black Hole Submission. In this lab, we will predict the mass of a black hole using Newton's law of gravitation and the results and analysis of given data to discuss the process, successfully predict the mass of a black hole and the motion of a star around it using a computational model, and answer the what if and what does it mean questions. The given data we were the data we were given is a star data file giving the positions of a star over time, the mass of the star, which is seen here, the time step, which is seen here, which is roughly 1 day, the positions of a black hole, which are seen here, and the G constant, 6.67 e minus 11 right here. We are also given the gravitational formula, which is usually equal to F net equals the gravitational constant times the mass of object 1 times the mass of object 2 over the distance squared. But it's modified because we are actually looking for the mass of object 2 or the black hole rather than F net. So mass of object 2 equals F net times the distance squared over gravitational constant times the mass of object 1. The data we are also given is F net formula, which is delta P over delta T when the time step is small. The distance formula, which is the distance is equal to the position of object 2 minus the position of object 1. This is my VPython model where you can see that I inputted the data for the black hole and the star. The star's mass right here, the time step, which is 1 day in seconds, 86,400 seconds. You can see the velocity formulas that I put in to correspond with the star data file that was given to me as I told it to read it. There is while the time is less than the star data, there's the change in x and the change in y formulas. Here is the initial and final velocity formulas. The initial and final momentum, which is the star minus the initial and final velocity. Delta v and delta p are equal to, and here dp dt is the correspondent for delta p over delta t, and we see that f net is equal to dp dt, the p hat, and the other formula is f net parallel, f net perpendicular, dp dt perpendicular, and then to save time, I go an extra step and write more code to figure out the mass of the black hole in VPython. I insert the gravitational constant, the distance formula, which is the square of x squared plus y squared. I then input the formula for the black hole mass, which is the magnitude of F net times the distance squared over the G constant times the mass of the star, which I showed earlier. And as you can see right here, here is what I did to make the arrows correspond with the F net perpendicular, and F net parallel. And I told it to print the F net and also print the black hole mass. And as you can see here, I will show what the model turned out to look like. Here you can see that the blue arrow is pointing towards the center or the black hole. The blue arrow is the F net perpendicular, yellow is F net, and the black line which goes along the trajectory, which you can't see because it's cut off here, shows the F net parallel. This is my F net that was given, and this is the black hole mass that was given to me, and it was proven to be true by Webb. As you can see here in WebAssign, the value that I found was proven to be correct. And in conclusion, the what does it mean and what if questions. What does it mean? How is F net perpendicular, F net parallel, F net different from delta P delta T perpendicular, delta P delta T parallel, and delta P delta T? F net predicts the forces that are acting on an object, while delta P delta T describes how those forces cause that object to move. They have the same magnitude, but delta P delta T describes how it moves, while F net just describes what exactly is acting on it. What if? Imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star was unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? In other words, is it possible for you to find a value for the mass of the new black hole that is different from the mass you found for the original one? The answer to this question is simply no. Because the force of the black hole, because the motion of the star was unchanged, that means that the same forces are acting on it as before. means this new black hole has the same mass as the original one.